Hello, we are discussing about GATE 2011 ECE paper. Look at the circuit shown. Find the value of RL such that the power transferred from the given circuit to RL is maximum. So this question is related to maximum power transfer theorem. A maximum power can be transferred. Okay, before going to discuss about the maximum power transfer theorem, we will discuss about few things when a maximum power is transferred from a source to load. So let us assume we are going with a voltage source Vs. Okay, every voltage source will have some internal resistance, that is Rs. So this is a general voltage source representation, which is a voltage source magnitude Vs and its internal resistance Rs. This voltage source can give maximum power, can transfer maximum power to a load RL only when RL is equal to Rs. When RL, that is load resistance, is equal to source resistance of this source, then maximum power can be transferred. The same thing can be said using maximum power transfer theorem. Instead of this voltage source, we are going to consider it as a complex network. From any complex network like this, okay, from any complex network, maximum power can be transferred to the load. These are the load terminals. Maximum power can be transferred to the load if the load resistance is equal to equivalent resistance of the complex circuit looking into those load terminals. So if you are going to get some equivalent resistance, that we can say it as it is equal to Rs of this circuit. So if you are able to find equivalent resistance of complex network looking into load terminals, then that value is going to be taken as load resistance. Then maximum power can be transferred from that circuit to RL. How do you calculate this R equivalent? Any complex network, okay, can be converted using Thevenin's theorem, can be converted into this VSRS form using Thevenin's theorem. Thevenin's theorem says any linear bilateral network consisting of many number of active and passive elements that can be replaced by a single equivalent circuit, which consisting of a voltage source VTH in series with equivalent resistance RTH. So any complex network that is linear and bidirectional circuit that can be converted into a single voltage source. That voltage source we call it as Thevenin's voltage in series with Thevenin's resistance or equivalent resistance across those two terminals. Now after converting, you are going to connect it load RL. So when RL is equal to RTH, then maximum power is transferred. This maximum power transfer theorem we are discussing with respect to DC circuits, because the circuit is given with DC sources, it is not consisting of AC sources. Okay. Now we are going to calculate RTH value. We are not interested in the calculation of VTH, we are only interested in calculation of RTH. So equivalent resistance, whenever equivalent resistance is calculated, then if any voltage sources are present, they will be get short circuited, and if any current sources are present in the complex network, they will be open circuited. So open circuit the current sources and short circuit the voltage sources to calculate RTH, short circuit voltage sources. So do that one now. This is a circuit of interest and it will be acting as short circuit. This is also acting as short circuit because it is a voltage source, and this gets open circuit. Okay, so the equivalent circuit is going to be looking like this is A terminal and it is B terminal. This is load terminals. From A there is a resistance 10 ohms to the B terminal, and this is what we have written, and one more 10 ohms is between A and B. Between A and B there is 10 ohms, and again one more 10 ohms between A and B. So this is one more 10 ohms between A and B, and next between the load terminals, these are the load terminals, and between load terminals and A there is one more 10 ohms. So this is the equivalent circuit. Now if you are going to write R equivalent is equal to 10 parallel 10 plus this 10. So 10 parallel 10 plus 10 ohms. 10 parallel 10 is 5 plus 10, which is nothing but 15 ohms. So R equivalent or R Thevenins is equal to 15 ohms. If RL is equal to R equivalent, that is equal to 15 ohms, then maximum power from this circuit is transferred to load RL. So the right option for this question is C. C is the right option for this question.